Bismillah ar-Rahman ar-Rahim. Today we are going to speak about the Wallis formula. This is a very useful formula for the trigonometric function with higher order, especially for the sine and cosine function. Before starting with the Wallis formula, let's give a very easy example, and then I am going to speak about the Wallis formula. Start with this example. Evaluate integration 0 to y over 2 of sine square x dx. Let's find the value for this integration. Definite integral between 0 and y over 2 of sine square x dx. We know that the sine square is equal to 1/2 1 minus cosine 2x. This is the half angle identity. Sine square x equal to 1/2 multiplied by 1 minus cosine 2x. So the integration for this one would be equal to 0 y over 2 of 1/2 multiplied by 1 minus cosine 2x, which is equal to, I take 1/2 outside, integration of 1 minus cosine 2x dx, and that will be equal to 1/2 multiplied by integration of 1 is x. Integration of cosine 2x is 1/2 sine 2x. This is by integration by substitution. Now to find the value, I will have 1 over 2, replace x by the upper limit, which is pi over 2. That will be pi over 2 minus 1/2 cosine, sine, not cosine, sine 2 multiplied by pi over 2. This is the value of the function at the upper limit, minus, no, the lower limit is x, is 0. So replace x by 0, this is 0 minus 1/2 sine 0. This is 0, and this will be also 0. So I will have 1/2 multiplied by pi over 2, which is equal to pi over 4. So you can see that if I have sine to power 2 or cosine to power 2, we can apply or we can use the half angle identity. But in some cases, I will have power higher than 2, might be 4, 5, or 8. For example, if I want to evaluate this integration, 0 to pi over 2, sine to power 5x dx. It's clear this can be written as integration from 0 to pi over 2 sine to power 2 multiplied by x sine to power 2 of x multiplied by sine of x dx. So I can apply the half angle identities for the first one and for the second one, or just half angle to power 2. It will be 1/2 1 minus cosine 2x all to power 2. And that will be complicated because in that case, I will have also cosine to power 2. And we have to reuse the identity of the half angle identity again and again. For this reason, we can use some formula or special cases of the integration, and that is what's called the Wallis formula. Wallis formula that if we have integration of different integral from 0 to pi over 2 of sine to power n x dx equal to pi over 2 multiplied by 1 by 3 by 5 up to n minus 1 divided by 2 multiplied by 4 by 6 up to n. This is if n is even, greater than or equal to 2. If n is an even number greater than or equal to 2, we can apply this one. It is pi over 2 multiplied by 1 multiplied by 3, 5, 6, or 7 up to n minus 1 in the numerator, divided by the even number 2, 4, 6 up to n. If n is odd, we will have 2, 4, 6 up to n divided by 1 by 3 by 5 by up to n minus 1. In case it should be n minus 1 up and n down. In case that n is odd, greater than or equal to 3. So if n is an even number, then the value of the integration is pi over 2 multiplied by 1, 3, 5 up to n minus 1 divided by 2, 4, 6 up to n. If it is odd, it will be 2, 4, 6. The even number will be up, and the odd numbers will be down without a pi over 2. You have to be careful about this one. If n is even, we have pi over 2. If it is odd, there is no pi over 2 in the front of the fraction. Also, the limits must be between 0 and pi over 2. This formula just applied if the limits are from 0 to pi over 2, or can be converted to these limits, 0 to pi over 2, if we have angle other than x. For the cosine, it is the same. Same thing for the cosine. 0 to pi over 2 of cosine is equal to. It is the same. It will be pi over 2 multiplied by 1 by 3 by 5 up to minus 1 divided by 2, 4, 6 up to n. If n is even, greater than or equal to 2, and it is equal to 2 multiplied by 4 by 6 up to n minus 1 divided by 1 multiplied by 3 by 5 up to n. If n is odd, greater than or equal to 3. For example, in our example, that sine to the power 5. Zero to pi over 2 sine to the power 5 x dx is equal to limits 0 to pi over 2. So these are okay. Power 5, odd number. So the value for this one will be 2 multiplied by 4 up to n minus 1. N is equal to 5. So n minus 1 will be 4. So it is 2 multiplied by 4 divided by 1 times 3 times 5. You can see that we use all the numbers from 1 to 5, 1 to n. But we split the even number up, even numbers are up, and odd numbers are down. You can see it is 1, 2, 3, 4, 5. We use all of them from 1 up to n. But we just split these numbers, putting the even number up and odd numbers down. So this is equal to 8 divided by 15. The value for this integration is 8 divided by 15. Take another example. Use cosine. Number 2, 0 to pi over 2. Cosine to power 8 of x dx is equal to limits from 0 to pi over 2 cosine. This is x, and the power is even. So I have n equal to 8, n minus 1 will be 7. So we should stop at 7 for the numerator. So since we have even power, we must have pi over 2 multiplied by odd numbers are up, which is 1 multiplied by 3 by 5 by 7, which is n minus 1, divided by 2 by 4 by 6 and 8. Is equal to, I can remove this 3 with the 6, it will be 2. So I will have up is 35 by multiplied by 2 times 2 is 4 times 4 is 16 multiplied by 8. It will be 128. So the 35 by divided by 128. This is the idea of applying the wireless formula. Number 3, let's find the integration of 0 to pi over 2 of sine to power 10 x multiplied by cotangent dx. I have sine to power 10 and cotangent to power 10. So let's simplify. I have 0 to pi over 2 multiplied by, and this is sine to power 10x multiplied by cotangent is cosine to power 10 divided by sine to power 10x. So I can simplify sine with sine. I will have only cosine is 0 pi over 2 of cosine to power 10x dx. Limits are okay, 0 to pi over 2 of x, and n is equal to 10. So this is n minus 1 will be 9 in the numerator. Since the power is even, we must have pi over 2 multiplied by 1 by 3 by 5, 7, and 9 up to n minus 1 divided by 2 by 4, 6, 8, and 10. I can simplify this one. I will remove 5 with 10. This will be 2. 3 with 6 will be 2, also there. So I'll have 7 times 9 is 63 by divided by, this is 8. 16 times it's 128 times 128 will be, this should be 16 times 2 times another 16 there. 16, this is 16 and 2. That will be 63 by 512. That is 63 by divided by 512. So this is the value of this integration cosine to power 10. Number 4. Find the integration 0 to pi over 4 of sine to power 6 of 2x. Now for this example, the limits are not 0 and pi over 2. This is pi over 4. But I don't have x, it is 2x. What I have there is 2x. So let's try to integrate by substitution and see, can we convert this limit to 0 and pi over 2 or not? So if we do it by integration by substitution, using integration by substitution. Let u equal to 2x. Then du is 2x or 2 dx. And dx will be 1/2 du. Now for the substitution, this one. If x equal to pi over 4, the upper limit, then I will have u equal to 2 multiplied by pi over 4, which is pi over 2. Now if x equal to 0, which is the lower limit, this will give me u equal to 2 multiplied by 0, which is equal to 0. So these are now the new limits, 0 and pi over 2, which means the integration now will be equal to 0, the new limit 0 and pi over 2 of sine to power 6 of u multiplied by dx, which is 1/2 du. So this is equal to 1/2 outside, integration 0 to pi over 2 of sine to power 6 u du. Which means that we can apply the Walli's formula. Limits from 0 to pi over 2, and the power is even now, n equal to 6, so n minus 1 will be 5. I have constant outside, I have to write it, this one. So it is 1/2 multiplied by. Since we have even power, we must have pi over 2 multiplied by 1 times 3 times 5 in the numerator, divided by 2 multiplied by 4 by 6 in the denominator. This is 3 with 6, so it will be 2. So I will have 5 by in the numerator divided by, this is 2 times 2 is 4, 8, 32, 64. So the value for this integration is 5 pi divided by 64. So you can see sometimes the limits are not 0 and pi over 2, but we need to check the angle of the trigonometric function, sine or cosine, and use integration by substitution to see, can we convert this limits to 0 and pi over 2 or not? If we can, then we can apply the Walli's formula. One more example, that will be number 5 now. Okay, see this one. minus pi over 4 to pi over 4 of tangent to power 8 x plus pi over 4 multiplied by sine to power 8 x plus pi over 4 dx. First of all, let's try to simplify this integration. Minus pi over 4 to pi over 4. We know that the tangent can be written as sine power 8 of x plus pi over 4 divided by sine to power 8 x plus pi over 4. Multiplied by cosine x by over 4 dx. Cosine to power 8 will cancel be with cosine to power 8. So the integration can be written as minus pi over 4 and pi over 4 of sine to power 8 of x plus pi over 4 dx. Now check the limits. These are not 0 and pi over 2. So let's try to convert these to 0 and pi over 2. Let u equal to x plus pi over 4. Now, if x equal to minus pi over 4, in the just use the lower limit, this one, I will have u equal to minus pi over 4 plus pi over 4, which is equal to 0. Now for the upper limit, x equal to pi over 4, u will be pi over 4 plus pi over 4, that will be pi over 2. So these are now the new limits, 0 and pi over 2. So the integration now, and plus one thing, I need to find du. Du equal to dx. These are equal. So the integration now will be from 0 to pi over 2 of sine to power 8 of u. And dx is equal to du. By Walli's formula, power is even, so we must have pi over 2 there. This is if we have even power. Multiplied by 1 times 3 times 5 times 7 up to n minus 1 divided by 2 multiplied by 4 by 6 by 8, which is equal to, take this 3 with 2 down, I will have 35 by divided by this is 2 times 2 is 4 times 4 is 16 times 2 is 32 times 8 will be 248. Okay, it is 32 multiplied by 8, which is equal to 35 by, and this will be 256. So it is 256. So the value for this integration is 35 by multiplied by or divided by 256. And this is the idea of the Wallis formula. The limit must be between 0 to pi over 2 when the angle is equal to x. And if it is sine or cosine to power, either even number or odd number, even power or odd power. If it is even power, we must have pi over 2. Then take the odd numbers in the numerators, even numbers in the denominators. If I have odd power, we don't have pi over 2, then it's equal to the even numbers in the numerators and odd numbers in the denominators.